Shujin Spatio-Temporal Digital Foundation Platform Tutorial Series, Episode 11. In this episode, we'll show you how to achieve automated pre-processing of remote sensing data using the platform. First, let's clarify what DOM is. DOM, Digital Orthophoto Map, is an image map created by processing remote sensing images through data fusion, geometric correction, mosaicing, and stitching. Its production process must follow strict technical specifications to ensure accuracy and usability. Nowadays, there's a dual increase in both the acquisition frequency of satellite remote sensing data and the timeliness requirements for monitoring by enterprises. So, how to produce DOM simply, efficiently, and automatically has become an urgent issue to solve. The Shujin platform offers 3 DOM processing modes: traditional, one-click pre-processing, and automated. The latter two support an automated workflow from tar.gz data packages straight to finished DOM products, making remote sensing data pre-processing much easier. In this tutorial, we'll focus on the one-click pre-processing mode and walk you through the full hands-on process. Let's get started. Step 1. Prepare reference data. First, you need to prepare the reference data for your target area: low-precision reference data, high-precision reference data, beam data, and color reference data. These ensure more accurate and consistent automated batch pre-processing. Step 2. Navigate the platform interface. Let's log into the Shujin platform first. We can see management modules here, including My Data, Vector Data, Image Data, System Settings, and User Center. Among these, My Data serves as a data center equivalent to a user workspace. Here, users can centrally manage all data, including cross-device, multi-type, and scattered data within their organization, quickly upload, download, and delete data, create new data folders, publish vector data and image data, flexibly publish image data as various services, and conduct automatic preliminary quality inspection on warehoused data. In vector data management, we can preview all vector maps, including 2D and 3D ones. Now, let's move to the most important image management module. It includes image management, layer management, service management, as well as offline services, public services, task management, and statistical information. In image management, we can see published image files. In layer management, there are published single-layer services. One layer may contain multiple image files displayed in a certain order. This is a drone image layer, which supports browsing and zooming at full resolution. In service management, there are published, customized, or composite layer image services. For example, a mosaic dataset will be displayed here after being published. This image management mode allows users to process, browse, share, and manage multiple types of image services more flexibly and efficiently. Let's continue to look at the functional interfaces for remote sensing image data, including offline services, public services, task management, and statistical information. These will facilitate users from satellite centers and data centers to efficiently produce and manage such data. So, how to publish data as services. The Shujin Data Easy platform has its own unique, fast, and efficient method. Go back to My Data. Open the data in one of the data folders. Here we can see a 4.91 gigabytes satellite remote sensing data file. We can view its attribute information, move its location folder, rename it, and browse it online at full resolution. Now, let's publish it. Check it, click Image Publish in the menu bar, and select the service method you need. For example, ordinary, layer, single layer. At this point, a dialog box for setting data time will pop up. Select Next. There are 2 sections here: Basic Settings and Advanced Settings. Through simple and quick settings, based on the platform's real-time online dynamic processing mode, we can directly publish this image data as the customized service we need, and it will be automatically and accurately mosaiced with the base map. We can set the projected coordinate system, service name, transparency, bands, zoom levels, stretching methods, supporting 4 stretching methods: linear stretching, histogram equalization, standard deviation stretching, and gamma stretching, as well as the data product type. For example, in automated pre-processing, we will need to use the option of reference images. Let's take a quick look at advanced settings. Here, we can set the satellite and sensor types for the data, configure the pyramid algorithm, and classify the data into a 4-level classification system. Meanwhile, to improve data retrieval efficiency, we can set boundary detection modes for it, such as bounding rectangle, inscribed quadrilateral, and accurate extraction. Now, let's name it and publish it. We can also check the option to publish it as a service simultaneously. Look, the 4.91 gigabytes data has been successfully published in the blink of an eye. Now, we go to layer management. The first one is the service we just published. Open it to browse. Zooming is very clear and smooth. We can also view its attribute information. Next, to supplement the part that is not available in the English version of the software, Shujian Data Easy has newly integrated 2 functional modules in the Chinese version computing platform module and process orchestration. The computing platform includes an algorithm library and task management, with more than 30 built-in algorithms. It enables data to quickly and seamlessly connect with algorithms and directly output results. The Shujian Data Easy team will also update the English version as soon as possible so that you can experience more complete and efficient spatiotemporal data management, processing, and sharing functions. Therefore, in the subsequent automated pre-processing demonstration process, we will use the Chinese interface for operations. The logic of this Chinese interface is basically the same as the English interface you have seen. The automated pre-processing algorithm is in the computing platform, and we will call it. If you're ready, let's get started. The layer management section is empty right now. This is where published data will show up later. Go to My Data. Here, we've pre-created a file directory called data_share, which contains 2 subfolders, DOM and UNTAR. The final results of automated pre-processing will be automatically saved in the DOM folder. Unzipped data will be stored in the UNTAR folder. Right now, both UNTAR and DOM are empty. We'll fill them up soon. Step 3. Publish the 4 types of reference data. Next, we need to publish the 4 reference datasets we prepared. Let's go through them one by one. 1. Publish low-precision reference data. Click Ordinary Layer, Single Layer, under Image Publishing. Set the parameters, Man Selection, 123, Layer Name, geo_base_low, Stretching Method, no stretching. Product Type, be sure to select Geometric Correction Reference Image, 1,4M. Click Confirm to publish. 2. Publish high-precision reference data. The process is almost the same as the low-precision one. Band selection, same as low-precision, 123. Layer name, geo_base_high. Follow the same naming rule. Stretching method, no stretching. Product type, select Geometric Correction Reference Image, 2M. Click Confirm to publish. Done. 3. Publish color reference data. Find the color_base file we prepared. Publish it as a single ordinary layer. Layer name, color_base. Follow the naming rule. Band selection, 123. Stretching method, no stretching. Product type, color correction reference image. Click Confirm to publish. 4. DEM data, not required for this case. Since our target area is a plane, we won't configure DEM data this time. After publishing, go back to Layer Management. You should see the 3 reference layers we just published. Step 4. The key part, Automated Preprocessing. Now, let's move on to the core step, Automated Preprocessing. 1. Go to the platform's computing platform, what we usually call the Intelligent Computing Framework. 2. Inside, you'll find Shuqian's algorithm library, which includes various algorithms for drone data processing, data preprocessing, AI-based applications, and more. These algorithms support seamless integration with data and are ready to use out of the box. 3. Enter the data preprocessing category and find Automated Preprocessing. Set the parameters. GZ package path. We've already prepared the data package in the tar folder under My Data. You can tell from the file extension. Unzipping path. Select the empty on-tar folder we saw earlier. Output path for results. Select the empty DOM folder. Intermediate files, you can choose to keep them, but we'll skip this for clarity. Click Confirm. The data will start automated processing, and no manual intervention is needed. Step 5. Check the final results. Let's take a look at the outcomes. The DOM folder, previously empty, now has a list of result files. The untar folder contains the unzipped original data. Layer management now shows the automated processing results. The 3 reference layers are at the bottom, and the newly published DOM layers are at the top. Verify result quality. 2 quick tips. To make sure the DOM results are up to standard, we'll use 2 simple checks. 1. Color consistency. Check if the DOM's color matches the color reference image. Go to Service Management and create a new service named color_s. In service layers, add the DOM results and the color reference data. To compare easily, place the DOM layer on top of the color reference layer. You can adjust layer order flexibly on the platform. Go back to Service Management and view the color_s service. You'll see the DOM's color matches the reference image perfectly. 2. Geometric alignment. Check if the DOM aligns with the geometric reference image. For example, do roads or building corners overlap? Create another service, follow the same steps as above, and add the DOM results and the high-precision geometric reference data for better accuracy. Browse the service, you'll see the paths between farmlands are accurately aligned. Feel free to check more paths or buildings to confirm. Why this mode works? The Shuqian platform's one-click preprocessing doesn't just simplify workflows and reduce technical barriers costs. It also systematically upgrades the service capabilities of traditional data centers. It connects the entire workflow. Data storage gives automated production, gives DOM result services. You can search for DOM data online, browse it visually, and even turn data results into online operational services. That's it for today. We'll release more tutorials later. Search for and follow Shuqian, making the sharing, management, processing, and application of spatiotemporal big data easier.